In my last video, I made a Padauk and bird's eye maple chessboard with a recessed bottom. So now I'm going to make a folding table that has a tabletop that's sized to fit into that recess. The table legs will be made from curly maple. So I'm starting with this 12-foot long maple. This is what it will look like when it's all finished. I'm using the jointer to flatten one face and one edge, and then I'll plane it down to clean up the top side. I only need 6 feet of length, so the remainder will serve as my backup piece in case anything goes wrong. Each leg will end up being about 33 inches long so that the top of the chessboard will be 30 inches high. This board is not wide enough to cut 4 legs, so that's why I need double that length to cut all 4 legs. The legs will be 3 inches wide, and this board is about 8 inches wide. With a table saw, I'll clean up the other edge and then cut 2 lengths that are each 3 inches wide. That leftover piece of curly maple will be perfect for making edge banding for upcoming chessboards. With a stop block in place, I'll cut each piece down to about 34 inches. The stop block makes it quick to cut each piece without having to measure each time. Next, I'll use the drum sander to clean up the edges and get everything down to exactly 3 inches. I'm eventually going to round over all the edges with a 1/2 inch roundover bit. So I want to mark all the measurements for where I'm going to place the stretchers that connect the legs together. It's way easier to measure while the edges are square, so I want to measure everything now on both sides of each piece. This first mark is at 1.5 inches from the end, so that I can position my compass to draw a semicircle with a 3-inch diameter. Then I'll use the bandsaw with a 1/4 inch blade to cut just outside that line, and then I'll clean everything up with a disc sander. This is just an inexpensive Harbor Freight sander, nothing fancy, but it does a good job of sanding right down to the line. Now, with the ends rounded and all the other measurements that I need marked, I'll round over all the edges with a 1/2 inch roundover bit. The legs are just a tiny bit more than 1 inch thick, so they will look perfectly rounded. I'm going to do a first pass with the bit only halfway up because there's a good chance that I'll get some tear out. And sure enough, I got some pretty significant tear out here. I was going to do a climb cut right from the start, but I was too worried that I would get nasty comments from viewers telling me that I was going the wrong way. So now you know why it's a good idea to use a climb cut for something like this. Now the bit is all the way up for the final pass. There's still some rough spots near the end grain that I'll need to clean up with the sander. Before proceeding any further, I need to prepare the veneer that I will use for the tabletop. This is the same veneer that I used on the underside of the chessboard that I had made 4 years earlier. I'm spraying it with the super soft veneer softener and conditioner, and then I'll clamp it flat for a week or so while I work on the stretchers. This first stretcher will connect the legs at the midpoint. I'm using the bandsaw to cut grooves to help find the center. Those grooves will help to lock into the spur at the drive end of the lathe. You can see how it will lock in with these grooves. This is a pretty simple operation. My goal is to turn this down to a cylinder with a 1 1/4 inch diameter. I'll start with a roughing gouge just to get it round, and then I switch to a parting tool to get it close to the thickness I needed, and then I used a skew chisel to clean it up and remove any variations in the diameter. And then I sanded it, starting with 100 grit, then 150 grit, and then 220 grit sandpaper. I want this stretcher to insert into the legs, so I'll use my parting gouge to reduce the diameter at the end down to 1 inch. This will insert into the leg by only 1/8 of an inch. This needs to be exactly the right length, so I'm measuring carefully before working on the other end. I don't want the fit to be too tight when it inserts into the leg, so I've turned it to be slightly less than 1 inch. Next, I will work on the other two stretchers. These will connect at the tops of the legs and will be used to support the tabletop. I don't remember the exact dimensions, but it's about 1 1/4 inches thick and likely 1 3/4 inches high. I'll turn the ends down to a 1 inch diameter, but I want to start with something a little larger, so that's why I cut it to be 1 1/4 inches. I'm going to turn only the ends of the stretchers to be round, so I need to measure these carefully. The rounded portions will have two different lengths because one stretcher will connect the outer legs and the other stretcher will connect the inner legs. On the bandsaw, I'm cutting those end portions so that they're only about 1/4 of an inch square. The top part of these two stretchers will support the tabletop and will fit into this 17-inch square recess at the bottom of the chessboard. And then I'll cut the grooves at the center point and then head over to the lathe. This piece is a little offset, so I'm going to start off very slowly because it's a little more dangerous with the center of mass offset like that. I especially want to make sure that I don't get my hand or the tool too close to the point where the size increases. There was a lot of vibration on this bench. I probably should have screwed it into the wall so that it could handle the vibrations better, because everything that was sitting on the bench was dancing around with the vibrations. After I got it roughly down to the 1-inch diameter, I carefully used a skew chisel to get into that corner, making sure that it didn't catch. And then I sanded it down with varying grits. These stretchers are also going to insert into the legs, so I will carefully mark where I need to turn them down to 7/8 of an inch. I need to make sure that these two stretchers match the length of the other stretcher that connects the legs at the midpoint. This is the other stretcher that has shorter ends to connect to the two inner legs. I'll trim off the excess of this first stretcher on the bandsaw to cut off the part that has a larger diameter, and then I'll square up the ends with the miter saw. Now I will use the drum sander to sand down the excess where it meets the rounded ends, because I want to round over the bottom edge with a 1/2 inch roundover bit. The top edge has to remain flat because that's where I will attach the tabletop. There's much less possibility of tear out with Padauk compared with curly maple, so I have the bit at the full height and I'm not doing a climb cut this time. Then I'll just sand it with my random orbital sander to smooth out the roundover. Now I have to drill recesses into the legs where the stretchers will go. I need to drill the recesses into both sides, so I'll start with a 1/8 inch drill bit to drill all the way through. This small hole will help me to position the Forstner bit on each side. I need to keep track of where I'm drilling to make sure that I'm using the right size of Forstner bit. For all the outside holes where the bolt head will go, I need to use a 1-inch Forstner bit, and I need to drill the recesses deep enough for the bolt head. On the inner side, where the stretcher connects, I only need a 1/8 inch deep hole, and it needs to be 1 inch diameter at the midpoint, but only 7/8 of an inch at the ends. Then I used an 11/32 inch drill bit to make a hole for the 8mm shoulder of the bolt so that it will easily fit through the hole. I'm using these bolts with a 50mm shoulder length at the midpoint where I need to go through both legs, and I'm using bolts with a 20mm shoulder length everywhere else. I'm going to put M6 threaded inserts into the ends of each stretcher. These inserts have a lip on the top, so they're meant to be mounted to the surface of the piece, but these are the only ones I could find that were large enough for the M6 bolts. So I'm starting with a 1/2 inch Forstner bit so that I can insert the lip deeper, and then I used a 5/16 inch drill bit to screw the threaded insert in. Next, I'm cutting some 5/8 inch Baltic birch plywood. The recessed opening at the bottom of the chessboard is about 17 1/8 inches square, so I'm cutting this to be about 17 3/8 inches so that I can trim it later after applying the veneer. The veneer should be flat by now, so I will unclamp it and then glue it to the plywood. I sanded everything lightly to get good adhesion, and then I used the veneer adhesive, used a roller to make sure the veneer would be bonded well, and then clamped it in place overnight. The next day, I trimmed off the excess. I had positioned the veneer on the top and bottom so that those excess pieces on each side could be used for one of the edges. This will help to match the grain. And then I have one more piece of veneer that I had flattened to use for the remaining edges because I don't have enough with just these two pieces. The next day, I trimmed the plywood down to 17 inches so that it wouldn't fit too tightly into the chessboard bottom. The only thing I regret is that I did not tape the edge before cutting it because I got a tiny bit of tear out. Nothing too major, but I know it's there. For all the other cuts, I taped over the veneer, and that worked perfectly with no tear out at all. I'm cutting the tabletop down the middle because it's a folding table, so the top will be in two halves. Now I'll put the veneer on those edges and clamp it overnight. The next day, I trimmed off the excess, and now I'm marking holes for rare earth magnets that I will insert into the mating edges of the tabletop. These do not provide any structural strength, but they'll help to lock the two pieces together at the time of assembly so that the table doesn't want to unfold while you're trying to screw everything together. I used a 12mm Forstner bit to drill holes just deep enough to hold two magnets on each side. And then I used Starbond CA glue to hold the magnets in place. I did that because there would be only thin veneer to keep the magnets from popping out, and that would have stressed the glued on veneer if the magnets were not stuck in place. Then I glued on these final two strips of veneer and clamped it again overnight. Then I lightly sanded off any excess glue and smoothed over the joints. You need to be very careful that you don't overdo it when sanding veneer because it's only about a 32nd of an inch thick. Now, at this point, I was getting pretty close to being done, so I sent photos to the client. They responded that it might be nice to have a Padauk stripe on each leg, so now I'm marking the end points of each stripe. I marked the ends to be 1 inch from each bolt hole and 1 inch from each leg where they intersect when the table is assembled. I carefully marked everything. The start and stop points are at a different position depending on whether it's the inside of the leg or the outside of the leg. So I had to transfer the measurements to the other side so that I could see the marks when running them through the jointer. And then I marked each stopping point clearly to avoid making a mistake. I used a spare piece of Padauk as my fence and marked where the router bit was so that I would know where to start and stop, and then it was time to make the cuts. I used a 3/8 inch router bit for this. There was the risk that something would go wrong, but I wasn't too worried because I knew that I still had that other 6-foot length of maple if needed. But I was lucky and it worked out well. Next, I used some pieces of Padauk that I had in my scrap bin and sanded them down so that they were smooth on both sides. I sanded them down to exactly 3/8 of an inch thick. Then I cut some thin strips on the table saw. I wasn't aiming for any particular thickness, they just needed to be thicker than the depth of the grooves that I had cut. I used my circle template to mark 3/8 inch rounded ends and then rounded them over with my disc sander. And then I marked the end and cut it at the miter saw, and then marked the rounded part and went back to the sander. It only took 3 or 4 minutes to get each piece to fix, so it wasn't that difficult. The first one's done, only 15 more to go. After getting them all to the right length, it was time to glue them in. The next day, I trimmed off the excess on the bandsaw and then sanded them down flush. Then I glued in the other side and trimmed them again. And now back to the tabletop. The magnets are good at holding the two pieces together, but they don't have much ability to keep them from sliding up and down. So I'm going to insert 2 dowels to help give them some structural support. I drilled the holes only into one side, and then I'll use dowel locating pins to mark the exact position of the holes to be drilled into the other side. This helps reduce measurement error so that I will end up with holes exactly where they need to be so that they match up. It fits perfectly, and the dowels give the tabletop the strength to not come apart when I lift it with only one hand. Now, with my dado blade, I will cut rabbets along the edge on the bottom of each piece to fit onto the 2 stretchers. I've taped the edge, but I've also clamped a board along the back side to prevent any tear out. Luckily, I got a clean cut. Now I will glue the stretchers. They're a little tricky to clamp because of the rounded edge, but I don't need a lot of force. I'm putting brass covers over each of the bolts, and we were unsure earlier about whether there should also be brass caps at the bottom end where there is no bolt. So I taped some on and sent a photo to the client, and we both agreed that it would look better to have brass caps there. So I'm drilling shallow 1-inch recesses to hold the caps. We also decided that the caps should not be flush with the leg to add a bit of visual interest by having them sit proud. This will also make it easier to remove them whenever they want to disassemble the table. And just when I thought I was done, one more last-minute change request came in. The client asked if I could put my logo and year on the tabletop, just like I had done on the bottom of the chessboard. I knew I wouldn't be able to use my CNC and fill it with epoxy because it would need sanding that would more than likely remove the veneer, so I decided to use my laser. This was a high-anxiety moment for me because there was so much that could go wrong. If something did go wrong, I would have had to have sanded off the veneer and reapply it. I'm so glad that the client pushed me to do it because it looks really nice and adds just one more bit of visual interest to the table. Now it's time to apply the finish and then assemble everything. Since everything had either a hole or a threaded insert to attach a bolt, I took advantage of that and hung everything on a wire so that I could spray on the lacquer finish on all sides at the same time. That made it easier and faster. Back inside the workshop, it's time to assemble the table. Everything is secured with bolts that will be concealed by brass caps. They are all M6 bolts, but the two bolts for the center stretcher have a 50mm shoulder to go through both legs, and the shorter bolts at the ends have a 20mm shoulder. I also used a black 25mm washer and a 3/8 inch lock washer. It just needs a 4mm hex key to tighten everything. The brass caps are actually stainless steel, made to look like brass, and they're quite inexpensive. They're 25mm, and the recesses have a 1-inch diameter, so they just press in to fit. Even with those magnets and the two dowels, the table would still collapse if there's too much pressure applied to the top, because there's nothing to keep the legs from splaying apart. But the chessboard fits over the tabletop, and that secures everything in place to prevent the two tabletop halves from separating. These brass caps add a nice visual appeal. Here are some photos of the final product. So I gotta ask, would you make it?